Hi everybody. Today we're going to work through, you can see the title up on the top, we're going to solve some polynomial equations. I think that this should be the next logical step in where we've been going with some stuff. So we've spent the last little while being able to manipulate the way certain algebraic expressions look, certain polynomial expressions. Now we're going to take that next step and we're going to actually solve some equations. What you see on the screen right now, and I'm just going to shrink it down just to make sure the whole thing is on there, is the list of examples that we're going to go through today. And I think by just walking through those 7 examples, we should have everything we need moving forward for any polynomial equations that come our way. So what I might suggest is, since you have that list of problems, jot them down, take a picture of it. But what I want you to do is I want you to pause the video and try to work your way through as many of those as you can. I'm going to argue that if we can get down to an attempt on problem D at the very beginning, then I think we're doing pretty well. Okay, I think we're doing pretty well. So what I'd like you to do is pause the video and get down to at least an attempt on D. And then we'll see if we match up as we go. Okay, best of luck. Okay, so we should be back then from having a pretty decent attempt on some problems. And really what we should be able to do, at least for the first few, is to go through pretty quickly. That is, when you're taking a look at A, this should just be a confirmation of a solution. That you notice that you have 2 terms that contain a variable. You can't put those variables together into one variable term, and so we're looking to factor or quadratic formula. So in this case, it's probably worthwhile to just take a quick peek. 2 numbers that multiply to give 3. I then have 2 numbers that multiply to give 8. And if I go a 2 and a 4, then I can get a negative 12 and a negative 2. There is my positive 8. Jot in your variable and your brackets. And we should pretty quickly get down to x equals 2/3 or 4. The only thing that I would not need to see in that solution would be your fast factoring method. Everything else in blue I need to see. Make sure you have a therefore in front of your final solution. Okay, hopefully we match up. Things went well. Let's take a look at B. Question B should have been actually very straightforward. And quite often we'll end up throwing problems like B at you way back in grade 10 as a bit of a stretch problem. So if you start to think about what you had at your disposal in grade 10, maybe we can see a pattern that hasn't been so explicitly described to you. Really, question B is just like question A. In fact, I might argue to you, I think B is easier than A. Because what I have in B is a simple trinomial. Now, I need everyone's focus to be on problem A. And I want you to look at the equation given to you in white in problem A. Because sometimes it isn't so explicit that the reason why you're able to factor that expression in that order is because you have a single something and a squared something and then a constant. That it doesn't necessarily matter what that single something is or what that squared something is, as long as they follow that pattern. A squared something, a single something, and a constant. That if you now change your focus to question B, you may notice that you have a squared something, a single something, and a constant. Now, sometimes that pattern will be even more explicitly stated as, look back on question A, the exponent on the middle term of that trinomial is half the exponent on the lead term. So now if we switch our focus to B, the exponent on the middle term is half the exponent on the lead term. And so I can factor the expression in the equation in B just as I would a normal simple trinomial. So my focus goes to the 100. I have 2 numbers that multiply to give 100 and add to give negative 29. That would be a negative 25. and a negative 4. Now, where I would normally just put in an x at the front of both brackets, I need it to expand to an x to the 4th, and I need it to have a middle term of x squared. That means that I have x squareds at the front of both those brackets. You can do a quick confirmation. If I re-expand, I get back to the original. Some of us maybe don't have that as like a key focus for us to be able to factor in that form. Just keep that in mind a little bit. Squared something, single something, constant. Now, I would expect that we should be able to jump straight down to x equals plus or minus 5 or plus or minus 2. However, I think some people would have experienced that they may end up making a mistake there. So I'm going to ask you to maybe put in 2 lines if you think you would make that mistake. That really what we end up having is this extra line in here that would say, therefore, x squared has to equal 25, or x squared has to equal 4. Like, in fact, we may have a line before that that would say, therefore, my first factor has to equal 0, or my second factor has to equal 0. But at the very least, if we come in with that second green line, then I think we should be good. So this becomes a personal thing for you. When you go to isolate your x in the equation x squared equals 25, are you going to remember that you have a positive and a negative case? Same thing with the second equation. So it's really particular. It's personal. It's up to you. If you are at all worried, you just go, oh, I know that's going to be me, I'm going to forget the plus or minus, then my suggestion to you would be to put in this green line. If we factor x squared minus 25 into a conjugates, and then factor x squared minus 4 into conjugates, because they're both differences of squares, that I'm going to almost guarantee that if you are able to, or if you do put in the green line, you're never going to forget about a plus or a minus, because you can see each individual solution there. Okay, all I would need to see is the red. You have to figure out maybe where you may make a mistake and just adjust. Okay, hopefully we can see that those are 2 grade 10 equations. So let's jump into problem C. We take a look at problem C, and all of a sudden we see that we've got a cubic, and so we might then have that idea, okay, now we're getting into some grade 12 stuff. However, I would argue to you that I could throw this equation at you in grade 10 or 11, and for some of you, you did solve this in grade 11. That we should have enough experience now to say, well, I can't put my x's together into one variable term, so I'm going to try to factor it. And before I blindly jump in and start using factor theorem, I'm going to check and see if it factors by grouping. And in this case, I notice that yes, I could pull out a common factor from the first 2 terms. And if I pull out a common factor of -1 from the last 2 terms, now my 2 terms have a common factor of x plus 3. And now I could state that x has to equal -3 from the first factor, or plus or minus 1 from the second factor. So a pretty quick solution on C. I just wanted to draw to your attention, is our default now factor theorem, or are we still working to have the best decision-making tree we can have? Okay, if it factors by grouping, take a quick peek, check, see if it does. Can really save some time. Okay, let's jump into D. Okay, this is where I asked you to get down to and at least have an attempt on it. My guess is that we're probably going to have to slot in some adjustments just for some form. But I would have some people that would have a perfect solution to this. I just want to talk about some process. So the first thing I can do is if I scan through all those terms, coefficients, is not going to equal negative 2/3. And so therefore, I notice that will not factor by grouping. Okay, so that means if that factors, then I am stuck using factor theorem. Okay, I'm going to put in all your communication in blue. Your solution will be in red. So, if we're going to use factor theorem, then we're going to label it as a function so we can talk about it correctly. Okay, everybody is on the hunt now to try to find some value that they could sub in that's going to make that equal to 0. And pretty quickly, we should be good that f of negative 1 is going to give you 0, and therefore x plus 1 is a factor. Okay, my next line then would need to be therefore, and we can begin. We have our factor. And now this just gives us one more good opportunity to confirm, can we compare some coefficients to be able to factor? So if we didn't get to this point before, then I want you to pause the video and just work your way through and see if we can fully factor that equation. Okay, so pause it now and give it a shot. Okay, and we're back. So we get a little confirmation. I'm going to have a 3x squared in my first term, and I'm going to have a negative 2 in my last term. As I now go through, I partially expand. There's a positive 3x squared. My original has a positive 8x squared. That means I need to add in 5 more. Okay, I take a look at that line, and now I'm going to check and see. So, can I factor that trinomial further? A 3 and a 1, and a 1 and a 2. And if I factor it that way, I can now get my positive 5 as my middle term. So I've got my x plus 1. Put in your variable and your brackets. And I can finish that off by stating, therefore, I get an x value of negative 1 from the first solution, or 1/3 from the first factor, the next factor, and then negative 2 from our last factor. Okay, I just want to have a quick conversation about that very first line and me sneaking in the blue. You guys can see that the blue is my communication. I actually messed up a little bit here. I should have this in blue if all of that blue is my communication. But that very first line of equals f of x, I just want to make sure that we're all good. That generally we've learned a rule that you should only ever have one equal sign per line. And so some of us may have been hesitant to write in that equals f of x on the very first line, since you can clearly see that there's already an equal sign in that line. I just want us to notice that we're not stating that that equation is really equal to another value. We're not stating that it's really equal to another expression. But really what that equals f of x is simply a name for that equation. And so it's okay for us to sneak in that little equals f of x and kind of break our there must only be one equal sign per line. Okay, now that we've seen our way through D, we're going to kind of build a little bit as we go through the next three. We'll get some opportunities to kind of test ourselves out, check our understanding, and I'll throw a little doozy in there for you. So let's jump into question E. Perhaps you were able to work your way through to E. I'm going to treat it as if we got hung up on D and nobody has attempted E. So what I'd like you to do is I'd like you to try to work your way through E. So I want you to try to solve that equation. Pause the video now. Okay, we're back. So the first thing we should have looked at is we have 5 terms, and 5 terms is not something that we are used to factoring by grouping. And we take a peek at all those coefficients and constant, and we're probably not quickly going through a factor by grouping option. So I think we had a very good strategy. If we looked at E and we said, I can't put my variables together, so I'm going to try to factor, and I'm going to choose to factor by using factor theorem. So we're going to work our way through. Our first goal then, let's label it with a name. And now let's go on the hunt. Factors of 30 that I can sub in that gets me equal to 0. Okay, well, maybe we use that little trick again, or that strategy of trying to get our coefficients to equal 0. So I've got this 30, and I have this 26. Those are pretty close, and they're opposite signs. So if I can put a little bit together with that 26, like if I put that 5 together with it, then that gets me up to 31. And if I put this 1 together, that's a 32. And my reds give me a 32, I notice that if I sub in 1, then that's going to get all my values to cancel out and get me 0. Now, in terms of space, I'm okay if you guys wanted to write beside it. Therefore, x minus 1 is a factor. Okay, we are good then to go through. So, therefore, x minus 1 is one of my factors, and now I have to build on the rest. I just want to draw to your attention a little bit how often people forget to write down that equals 0 on the right side. I don't know if in terms of form there was a more important point for us to ensure that we get down. Don't make the mistake of all of a sudden changing an equation into an expression. It's going to come back to haunt you later. So make sure that we have that equals 0 down on the end. And now we're going to go through and we're going to compare coefficients. So this one gets a little bit uglier just because we have to get back to that quartic. So what I'd like you to do is pause it now and try to see if you can come up with that other ugly factor. Okay? Pause it and give it a shot. Okay, we're back. So, we should have been okay to start it off with my 2x cubed and to finish off with a negative 30. However, we may have stumbled a little bit. Right now, if I expand that, I have a negative 2x cubed. I have to get back to, and I'm just going to highlight it, a negative 5x cubed. So I already have negative 2. I need to get to negative 5. That means that I need to include another negative 3 of them. However, I may not have the complete factor because there could be some single x terms in there. So what I need to do then is partially expand one more time. If I was to expand my brackets now, I would have a positive 3x squareds. I'm just going to highlight, back up in the original, I'm supposed to have a negative 26 of them. So I have positive 3 of them. I need negative 26 of them. That means that I need to subtract 29 more of them. And so just notice, if we're missing extra terms or we have a more complex expression, we can just keep comparing coefficients and slowly expanding. Okay, well, let's take a look at what we have inside that second set of brackets. And notice we have a cubic, we have 4 terms, and that's not going to factor by grouping. Oh, so we're stuck doing factor theorem again. No worries. Okay, before anybody thinks that maybe they have to sneak in a little equals g of x or something in this context, stop, you don't need it. That equation is still called f of x. And we can still use the label of f to go through and try to find the other factor. Keep in mind, let's just imagine that if what I was supposed to sub in was happy face, then if I wrote that f of happy face gave me 0, I don't care that it's just this factor that I'm subbing in for. Because if I can get that factor to equal 0, I don't care about this first factor that was happy face minus 1. Because 0 times anything gives me 0. Who cares about the first factor? So I'm just going to get rid of all that scribble I just wrote down and make sure that we're good, that we do not have to label it, with a new function. You can, it's no harm, but feel free to just keep using your same label. Okay, I think we should be able to finish this one off. So let's pause the video now and try to finish it off on our own. And okay, we're back. So I'm going to go through now and come up with another value. Well, if I go through, I can get 32s again. Except a little bit of my problem is if I sub in a positive 1, then I'm going to get 2 minus 3 minus 29 minus 30. That's not going to get everything to cancel out for me. If I sub in negative 1, then I get a negative 2 minus 3 plus 29. That's not going to cancel out. So even though my coefficients could get me to 32s, I can't get the great signs to get them all to cancel out. Shoot. Well, then I'm going to keep working my way through. Maybe I try like an f of 2, because that's going to get me 8 times 2 is 16, minus 12, minus, and as soon as I start to do that, we may start to see that if I'm subbing in some positives there, all those other subtractions might not allow me to get back to 0. And so maybe my motivation then goes, well, I think I'm going to have to sub in some form of negative to try to get that 29 term and my constant, my 30, to have different signs. So if I sub in a negative 2, then I'm going to have negative 16 and a negative 12. But now when I sub in my negative 2, I'm going to get a positive 58. And I really love seeing that because now everything cancels out and I get my 0. And therefore, x plus 2 is a factor. Nice. I was able to go through and find another one. So I have the x minus 1 original factor, my x plus 2 factor that I just found, and now I'm trying to work backwards, and I'm trying to get back to that cubic that I just identified. Okay, so my leading term is going to be a 2x squared. I know that my end has to be a negative 15 because I'm trying to get back to negative 30. And now I can partially expand. Right there is a positive 4x squared. I need to get back to a negative 3 of them. That tells me then that I need positive 4 subtract 7 of them gets me back. Now that I have that factored and I have that next factor that ends up being quadratic, oh, that's super fast. Okay, I want that to be in purple. 2 numbers to multiply to give 2. A 5 and a 3 will allow me to get to a negative 7 with those signs. And so I can fully factor that expression. And now I'm allowed to finish off with an x value of 1, or negative 2, or negative 3 halves, or 5. And for everything that we talked about before, you're okay to put in commas instead of writing in the word or, even though we know mathematically commas mean and, but it's okay in this instance. Now, okay, there we go. I'm going to argue to you guys that that is probably one of the ugliest equations you guys would have to solve. I just want to draw your attention, though, to it's not really difficult. Now, there's a lot of space to be able to make a mistake, but it's really just long. Like, there's more work to do, but it's not really difficult work. We just had factor theorem that we had to use twice. Okay, let's move into one other problem. Okay, I'd like you guys to take a look at f, and I'm going to argue to you that I think f is a really good gauge for us. Can we work our way through solving f? And if we can on our own, I think you're probably pretty good for anything I could throw at you. So, I want you to pause the video now and work your way through and solve f. Okay, we're back. So, I think we should be able to work our way through pretty quickly. We sneak in a little function notation. And if I worked my way through, my ones aren't going to work because I can't get two of the same numbers. So, I'm going to try, I'm looking for factors of 10. And on quick peek, I think if I sub in 2, I'm going to get 8 plus 4 minus 22 plus 10. That gets me to my 0, and therefore x minus 2 is a factor. So, I now have my x minus 2. I know that I have to start off with an x squared. If I expand right now, I see I get a minus 2x squareds. I need plus 1 of them, so I need another positive 3 of them. And I can see that my last term has to be a negative 5. Okay. Now we take a peek. Well, on that last factor, there are no two numbers that multiply to give negative 5 and add to give positive 3. So I recognize that that factor does not factor further, and I am not fazed by it whatsoever. Because I can see in the first factor, I can get a solution of x equals 2. And if I have a quadratic, really, this is all that's happened. Therefore, x squared plus 3x minus 5 has to equal 0. I end up with a quadratic equation. Now, you never have to write down that blue statement. If we recognize that it doesn't factor, then feel free to just jump in and use your quadratic formula. So, therefore, x equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 5. Just use your quadratic formula. We get down and we see that root 29 is not going to reduce, and therefore the whole expression will not reduce. And there are your 3 solutions. As we said before, don't ever feel like you have to rewrite out both those distinct solutions of negative 3 plus root 29 halves and negative 3 minus root. No, just leave it as that and you are good. So hopefully you can look back on f and you can see this is why I think it's a good gauge. If we were able to recognize that when something doesn't factor, we use quadratic formula, even in this cubic case, then I think we're showing good perspective. Okay, now let's work our way through a doozy. So, what you see in G, then, I would call this one a doozy. And we're going to spend considerable time on this one. So, I want you just to get down your first line, and I mean the first line of this of your solution. And I think we should be pretty quick. So, pause the video now. Okay, we should be fine to get going. I think we should have been okay to simply say, okay, therefore, and then go through and solve the first factor equal to 0, the second factor equal to 0, and we're good. The first one we notice factors, the second one we need quadratic formula, we are totally fine. you might have been asking yourself, okay, why did Greg call this one a doozy? Like it was actually pretty straightforward. And yes, it should be pretty straightforward. The reason I'm going to call it a doozy is because I'm going to change something in the question now. That what I'm going to do is I'm actually going to change that 0 on the right side to a 10. And I'd like you to do the same. And now I'd like you to go through and try to solve this new equation. That really what I'm trying to challenge you with is your strategy. So, before you go too far in a bad direction, I'd like you to do the same thing. I'd like you to just get down your first line, and then I want you to stop there. I think that first line is going to challenge our strategy, and we'll learn something pretty valuable just from that. Okay? So, pause the video, get your first line down, and then come back. Okay, and so we're back. So, again, I just want to challenge strategy a little bit. That if our instinct was to do something like this and expand those brackets to collect like terms, to move that 10 over and write into standard form, then I think our gut instinct is good. I want to be very clear, that is going to end up being a horrible decision in this case. However, our gut instinct is leading us down a good path. So again, I'll take a little bit of that blame of I see brackets, I expand. We're going to talk a little bit later about why that decision was a bad decision in this case. But as I said, to go through and expand the brackets, collect like terms, bring the 10 over, I think that that's telling you you have good strategies. So what I'm going to tell you then is let's not do that. So some of you might be wondering, okay, well then why did you have me do that? I think it was so important for you to take the strategy and then maybe learn that it didn't work out well, to then be able to remember that experience so that we can apply it later on. Okay, so if I'm going to tell you that you don't want to expand this problem, don't expand the brackets. Okay, now what I want you to do is I want you to try to give another shot. So I want you to pause it and try something else. Again, one line only. Okay, pause it now. Okay, we're back. So I would not be concerned at all if we were stumped. Like if we were in a case where you were like, hey, you took away my only strategy, which was expand the brackets, collect like terms. Then I think that's okay if we were stumped. I do want to address just a couple things that we can maybe nail down in terms of, okay, decisions that we could have made and maybe were they good, were they not? The first thing that I want to draw your attention to is we do have an instance where we have something times something that equals 10. And so I don't think it was that bad if we said, hey, well, that's two things multiplied together that give me 10. So maybe I'm going to view that as like 2 and 5. So I'm going to make that first factor 2 and my second factor 5. And notice that what you just built were two quadratic equations, and you can solve any quadratic equation, your factoring or formula, we're good. I just want to draw to your attention why that's not a good strategy. Like, keep in mind that it could have also been 5 and 2, so we would have had another possible solution. Keep in mind that it could have been 10 and 1 or 1 and 10. Now, some people are going to look at that and go, yeah, but that was only 4 possible solutions. Like, that's not that bad. It would have taken some time to do the work, but it's not that bad. Okay. Here becomes the problem. Keep in mind that that first bracket could have equaled 3. If the second factor equals 10/3, yeah, remember, like, I can have any two values that multiply together. Like, my first bracket could equal happy face. as long as my next factor equals 10 divided by happy face. Now, those two things multiply together to give me 10. So maybe we can see why that wasn't a good strategy. I commend you, though. Like, if there was nothing else that you were able to think of, then at least that's something. Maybe we ruled that out because we kind of saw that theory. Okay, I want to walk through a solution to G, because this can be a method that you can have, a strategy that you can follow when you happen to get something that's a little uglier. Again, we're going to talk about why you should not expand your brackets in this case, or what assumptions you're making when you do. But if we were to tackle something different, use a different strategy, I just want you to notice that when you look at your two factors on the left side for G, that they both start off with the same two terms. That might have been something that jumped out at you. Maybe it was something that you totally overlooked. Notice my first factor and second factor both start off with x squared plus 5x. And if those two terms could be represented by one term, then I could simplify the way the expression looks. So maybe we end up using a little substitution to say, I'm going to let something else, a, b, whatever, as long as it's not an x, equal x squared plus 5x, because now I could substitute in, and I could get something like that in red. Now, I want to stop there because this is where we can have our discussion about why we should not have went through and expanded the original line, or why in this case it would not be a good action. When you take a look at expanding that top line, the original equation, we could see that we're going to get an x to the fourth equation. And I need you to keep in mind, are you able to solve all quartic equations? And the fast answer to that is no. That we're able to solve quartic equations if they factor, number one, and when they factor, if they have a linear factor. That is, if we're able to go through and deal with an x minus b factor. That's what we need to have in there to be able to go through and factor it to eventually solve. I told you that's the limit of the course. Well, even if there was an ax minus b factor, then we could factor it. But you only know how to solve quartics if there is a linear factor. So when you expand all those brackets and collect like terms, you may be creating an equation that you don't have the means to solve. What if there isn't a linear factor in there? Then we don't have a method to solve it. I want you to notice your red equation. When we expand those brackets, you can see that you're going to get an a squared. You're going to get a quadratic equation. And can you solve all quadratic equations? Yes, because you have factoring, but you also have quadratic formula. So that is why we're good to go through and expand the brackets in the red, because when you get down to solving, when you get down to writing in standard form that red equation, it doesn't matter whether you can factor that expression or not. You can still solve it. Back in my original, your only way to solve it is by factoring. Shoot, we would be in trouble. Okay, let's jump back into that red. I'm just going to eliminate my little notes off to the side, and let's go through and actually solve this thing. So I love the fact that that does factor. Two numbers that multiply to give 18 and add to give 11 are 9 and 2. Now, some people, just out of habit, may then want to come through and write, therefore, a equals. I just want you to keep in mind that nowhere in that equation did I ever ask you to solve for a. So if you chose to go through and solve for a, you're going a little farther than what you need. I then want you to notice that if you're then going to sub in and re-substitute back in your original expression, notice you kind of have to do a little bit of backtracking. That you would then have to, okay, bring that 9 back over. So after seeing this process, maybe we can get rid of all that blue. And instead, let's substitute right now. That we're going to sub back in our a value, which is equal to x squared plus 5x. Because that is going to give me an x squared plus 5x plus 9 factor and an x squared plus 5x plus 2 factor. And the key, that is now equal to 0. So when we changed that equation away from equaling 0, and I plugged in that 1 to equal 10, we needed a different strategy. But now that we have the blue equation on the bottom, we love that. Because now that's equal to 0, we're good to go. So I'm just going to shrink that down a little bit, just to give a little more room. And we can now deal with both of those individual quadratic equations. So the first factor has to equal 0. So I'm looking for two numbers that multiply to give 9, add to give 5. That isn't the case. So therefore, my x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I get down to negative 5 plus or minus the root of negative 11 halves, and we should very quickly be able to say no solution to that equation because of the negative under the root. Okay, as I said, I'm running out of room a little bit, so I'm going to solve the next one up here. So x equals negative 5, and I can tell that I need my quadratic formula again because I don't have two numbers that multiply to give 2 and add to give 5. And I can solve that quadratic equation, but I want you to take a look at your roots. And there are my two answers. So I get two solutions to this equation. Negative 5 plus root 17 halves, negative minus root 17 halves. Now, I just want you to look back at this for a second, just to gain some perspective. Let's say that we went through and we expanded our brackets, collected like terms, put it in standard form, and then tried to use factor theorem. I just want to draw to your attention that what you would have to do when you called that f of x is you would then have to go, let me see. Yep, I think when I sub in negative 5 plus root 17 halves, I think that's going to give me a 0. And I hope you can see how ridiculous that would be as a means for trying to solve. There's no way you see that. But because we can see our only two solutions to that equation, that's what we would have to do by using factor theorem. So I just want to draw your attention again. If we expanded, we may be creating an equation that we really don't have the means to solve. And so one of our strategies might be, before we blindly expand, is there a pattern in there somewhere? A way that I can simplify the equation and make it an easier equation for me to solve. In this case, we could use substitution to do so. If there was no pattern, then the only means we would have to be able to go through and solve would be to expand, collect like terms, and go. So that's why I said at the very beginning of this problem, hey, I think that would have been a good instinct to do it. We now see that maybe we have another strategy to use. Okay, that's it for today. Your job, jump in and get some practice and try to make solving what I think you can picture your standard equations to be pretty automatic. Okay, good luck.